Conservation of momentum applies when things are going to go through what I call an explosion, when we have one object, one fairly big object, that splits into two or more parts. We'll go through two examples, a one-dimensional one and then another video clip with a two-dimensional one. As always, to help visualize, I'm always going to push you to draw a diagram. I'm not going to try and draw an astronaut. I'm going to be a little bit lazy here. This is going to represent our astronaut. Astronaut has a mass of 65. And our astronaut is holding on to a 14-kilogram toolbox. That's going to be our toolbox. They're drifting, I'm going to say this way is forward at a speed of 3. The astronaut pushes off on the toolbox so that the toolbox ends up going forward at a speed of 10. I'm just making up these numbers. So after that, the 14-kilogram thing is going forward at a speed of 10. And then the astronaut, most likely still going forward, but I'm not sure how fast she's going. Classic conservation of momentum. Whatever is going on initially, we'll have the same momentum finally. In explosions, the objects are connected to begin with, so I usually do something like this, MA plus MB. Sometimes it's like little m and capital M. But the sum of those two masses, since they're together as one body, they're going the same speed, and then it splits into two after. Mass A is going to be going some speed. I'm going to call it VA with a prime to indicate that it's after, and mass B is going at some speed. I'm going to call it VB prime with a VB with a prime to indicate that it's after. In this particular explosion now, for what's given, we know everything but what I called VA prime. I know the two masses, and I know the one speed. Oh, sorry, two speeds. So plugging in numbers, 65 and 14, we're going a speed of 3. Then after the collision, 65 is going, I'm not sure how fast, and the 14 was going 10. If we do our algebra, 65 going I don't know how fast, I get the 65 and 14 multiplied by 3. I got that to be 237. Flipping the 14 times 10 over, that's of course 140. A little bit of algebra. After clearing the 65, I get that the astronaut's going 1.5. Since I got positive, momentum's a vector. Since I got positive, that means it's in the same direction that I was going in as the 3, since I put the 3 in as positive. So the astronaut is drifting forward at 1.5 meters per second. Kind of as expected, to throw the toolbox forward, she put a forward force on the toolbox, equal and opposite reaction, that puts a backward force on her. So throwing the toolbox forward is actually going to slow her down a little bit.